Okay, first of all, starting with our non-permissible values. Again, we're going to take our function that I originally had here, and we're going to factor it completely if we can. And there's a difference of squares on the bottom, so we get x plus 5, x minus 5. And unlike the first one, nothing cancels out this time. Okay, so our non-permissible values, x can't equal 5 and x can't equal negative 5. And this time, these will both be vertical asymptotes at x equals 5 and x equals negative 5. So that's our sort of step A, looking at our non-permissible values and figuring out if we have holes or vertical asymptotes. Since this one didn't simplify to a line, we do have to look, are there going to be horizontal asymptotes for this one? Are there going to be oblique asymptotes? So the way that we did that in 2.3 is we looked at the highest power in the whole equation. The highest power, highest degree that we have either in the numerator or the denominator is x squared. So if we look at just the x squareds and ignore everything else, we have negative 2x squareds in our numerator, and we have a positive 1x squared in our denominator. Again, the idea being that as x gets really, really big, subtracting 25 on the bottom isn't going to make that much of a difference. It's really what's happening between negative 2x squared and x squared. And if we simplify this, the x squares cancel out, and we get y equals negative 2, and this is a horizontal asymptote. So this equation is going to have a horizontal asymptote. It's not going to have an oblique asymptote. So now we got both of our asymptotes. We're going to see if we can find our intercepts. Yeah.
How do you know whether it's a horizontal asymptote or an oblique asymptote?
The horizontal asymptote will always happen if what we have here can be simplified to something so that it is like a number. You will always get an oblique asymptote when, let's say, the highest power was an x squared. You had one x squared on the top, but you had no x squareds on the bottom. So whenever you're dividing and you get a 0 on the bottom, that's not possible. And that's going to tell you you're going to have an oblique asymptote. Anytime it's possible, then it'll have a horizontal asymptote. Anytime it's not possible, you're going to have an oblique asymptote. So for part C, finding our intercepts, again, for an x-intercept, plugging in y equals 0, that only happens when your fraction, the numerator, is equal to 0. So looking at the negative 2x squared in your numerator, the only time that's possible is when x is equal to 0. For our y-intercept, you would plug in 0 for x. Again, going to our equation, just putting zeros in where the x's are. That will also give you 0, which makes sense if our x-intercept was at 0, that our y-intercept would have to be at 0 as well. So now we've got our asymptotes and we've got our x-intercepts. This will be one, though, that when we plot all of those things in, we are going to need an extra point. And here we're going to have a look at it. So set up our axes. One asymptote at y equals negative 2. We have two vertical asymptotes at x equals negative 5 and x equals 5. And what we know so far is that it went through 0, 0. Okay? Now, when the textbook says what happens as it gets close to our asymptotes, to figure out what's happening to our graph, as it gets close to our asymptotes, one thing you can do is plug in values that are near our vertical asymptotes. And for sure, we're going to need some values to the right of x equals 5 and to the left of x equals negative 5. It's not bad to also have some more values in the middle as well. But as a minimum, let's start with what happens when I plug in x equals 6. Probably the easiest thing would be to look at our factored part here. On the top, I'm going to get -2 times 36. It's a big number. And on the bottom, I'm going to have 11 here and 1 there. -72 over 11. Which is roughly about 6.5. So if I was going to graph that, I know that I have a point down here at 6 comma -72 over 11. I'm just sort of going to estimate where that is. Yes? Well, we need that point because here we're wondering, is this graph in this section like that, or do I know that it's up here? Okay? Now, you could say, since we found our only x-intercept to be at 0, then it would have to be down here. Otherwise, approaching the asymptote would cross the x-axis again. But this shows that you've plugged in a point. It's not always the case that you could use that as a shortcut. So then you would have to plot in a point, especially if the asymptote was on the x-axis. Plugging in -6, because we're dealing with symmetries here, if you plugged in -6, you would get exact, no, you'd get exact same thing. Let me just check up here. Yes, because you'd have -1 and -11 on the bottom. And so this section would also look like that. Now with our point 0, 0, and with our asymptotes the way that they are, you can probably guess that this section is going to go up like this and not through the asymptote. That's what we're going to assume is going to happen. What we could do to check is we could put in a value of 4 and -4. They're going to be the same because it is symmetrical. But if I plugged in x equals 4, and again, like I said before, using a table of values in these questions, the more, if you're ever unsure, just keep plugging in values of x and getting more points. That'll give you more data points to see what your graph is going to look like. So when I plug in 4, I'm going to get -2 times 16. On the bottom here, I'm going to get 9 and -1. So I'm going to get -32 divided by -9, which is roughly 3 and a bit. I can plug that point in if I'd like, and similarly, I'd get the same thing on the other side. So then I've got more points, and I'm more confident that that's how my graph is going to be. And then I just draw my curves so that it approaches asymptotes. Questions you can do for this one. Number 4.